All right, guys, Dr. Kruse here. In this statistics video, I'm going to go over some simple probabilities and show you how to calculate expected value and standard deviation. All right, looking at this simple table, somebody measured the probability of spending all day at this pond and catching this number of fish. So X is the number of fish that you caught, all right? And the P of X is the probability of catching this many fish, of catching X fish. So at this particular pond, you can spend all day sitting there, and the probability of you catching 0 fish, if X is 0, the probability of 0 is 44%. So you could sit there all day and there's a 44% chance that you won't catch any fish. That's 44 out of 100. So you could sit at that pond 100 days, all day, and 44 of those 100 days you would catch nothing. All right, if X is one fish, what's the probability of sitting out there all day and catching one fish? 36%. So out of every 100 days you sat out there, 36 times you'd catch one fish. What's the probability of catching two fish sitting out there all day? 15%. Out of every 100 times you go fishing at this pond, 15 of those times you'll catch two fish. What about three fish? 4 out of 100 times, not very many, 4%. And what's the probability of catching a whole bunch of fish? 1%. So out of every 100 times you went to the pond, one of those times you would catch 4 or more fish. Now note that the probabilities are valid. They add up to 100%. If I asked you something like find the probability of catching one or more, that's the probability of catching one or more, or more, or more. All right, I could catch all of these. I could catch one, I could catch two, I could catch three, I could catch four. I'm just going to add those probabilities up, and they add up to a 56% chance of catching one or more. Now remember, when you say one or more, there's a quicker way. If I'm talking about 36 and 15 and 4 and 1, a quicker way is just to start with your 100% and subtract out the only one I wasn't talking about, the 44%, and you'll wind up at the same place, just a little bit quicker. All right, let's compute mu, which we've called population mean in the past, or population average. It's kind of what we expect to happen. So we also call it expected value. How many fish do we expect a fisherman to catch? All right, so expected value, mu, is the sum, that just means add, summation, add them all up, the sum of each number of fish times the probability of catching that number of fish. So the first one would be catching 0 fish times the probability of catching 0 fish. This is out of the table. So 0 times 44% plus 1 times 36% plus 2 times 15%, and so on. It's each X times the probability of that thing happening. And so we work this out all the way through the table, all the way to the end. 4 fish times the probability of catching 4 fish. And we end up with 0.82, which is kind of hard to explain. This is the expected number of fish caught per fisherman. So for each guy out there fishing, we expect him to catch 0.82 fish. Now that's not even a whole fish, so it's kind of hard to put in context. It's easier if you think 82 out of 100, because 0.82 is 82 100ths. So if you think of it as 82 out of 100 times, so think of it that way. Out of 100 times that a fisherman goes to this pond, 82 of those times we expect him to catch a fish. So not every time, all right? We expect him to catch less than a fish every time, or you could think of it as 82 out of 100 times he'll catch a fish, but he won't catch a fish every time. We don't expect that he'll catch a fish every time. We expect him to catch less than a fish every time. All right, and then standard deviation just goes with it. Now this is a little tricky, but you guys will see the pattern here. Standard deviation is, well, first we got to find each deviation. So this is the number of fish caught minus what we expected them to catch. That's deviation. So for 0 fish, all right, for 0 fish minus, so a person caught 0 fish minus what we expected them to catch, that's the deviation, which we have to square, part of the formula, times the probability of 0 fish. That was 44% chance that you would catch 0 fish. Summation means add all of these multiplications up. So this is our first multiplication plus, okay, what about one fish? Well, one fish minus, we expect you to catch part of a fish, square the deviations, times the probability of catching one fish plus two fish minus the expected value times the probability of catching two fish plus three fish minus what we expected you to catch times the probability of catching three fish plus catching four fish minus what we expected you to catch times the probability of catching four fish. All right, now we wind up at 0.899 for a standard deviation. And how you do it just depends on your calculator. If you have a TI-84 where the root just kind of keeps extending and extending and extending as you type stuff in, then you don't need these extra set of red parentheses. That's for the TI-83s. So you guys on the TI-83, when you hit root, it's going to start this parentheses right here, and then you just need to remember to add all the other parentheses. With the 83, you have to tell it when to start rooting and when to stop rooting. All right, because it doesn't have a nice picture like the 84s where the root just keeps extending. So on the 83s, make sure you hit root, this one appears, and then start right here with this parentheses, enter everything, and then make sure that you close the final parentheses, and you'll end up at 0.899. Just by the way, if you forget to square root, you'll end up with 0.8076. So you got to remember to square root or else you'll end up here. All right.